So we are going to be multiplying rational expressions today. So a lot of what's going to happen today, besides us, we have to factor to see what factors we have. Then we are going to look for ways that we can simplify and then combine. So let's look at this first one. This first one isn't going to have anything we have to factor out. We just have to look at the factors of the numbers. And so let's look at what it is when we have 3x divided by 35y times 49y divided by 12z. And so I'm going to use different colors to show the what I cancel with each other. So the 35 and the 49 are both divisible by 7. So 35 divided by 7 is a 5. 49 divided by 7 is 7. Next one I'm going to look at is that 3 and the 12 can also reduce. 3 divided by 3 is 1. 12 divided by 3 is 4. And then the next thing I'm looking at that can reduce is my y's. They both exactly match. They just actually cancel out there. And then my answer is going to be when I multiply things together. So 1 times 7 is 7. X, and there's no other variable, so that's just an x, divided by 5 times 4, 20. And then the y was canceled here, leaving us just the z. So that is the product. The other part it asks for is the restrictions. Let's look at the restrictions. So again, what we can't have is a 0 in the denominator. So I look back up at the original problem. My variables that were in the denominator were y can't equal 0, z can't equal 0. So those are my two restrictions in this problem. So let's look at one that we do have to factor a little bit more. So let's look at the terms that need to be factored. X minus 2, there's nothing in common between these two. So there's nothing that can factor out. So I just write it down as is. 5x is just a monomial, so there's nothing to factor there. So I write it down as is. 10x is a monomial, so again I write it down just like it is. Now I get down to my denominator. When I look at this, there is a common factor between the 3 and the 12, and that common factor is a 3. So the first thing I'm going to do is factor that factor out. That leaves me with 3 times x squared, because 3x squared divided by 3 is x squared. 12 divided by 3 is 4. Now I've got to take this factor, because it's squared still, and use my box to factor it. So the x squared goes here, and negative 4 goes here. Multiply those together and get 4x squared. What two things will multiply to give me 4x squared that will add? There's not a middle term here. That means it needs to add to be 0, so they need to cancel out. And so that gives me 2x and negative 2x. And if you remember when we were learning factoring, we talked about something called the difference of squares. This could have been done with that rule. You didn't have to use the box in this problem. And again, when we're using the box, remember we're looking for what is in common in this row. And this row has an x in common between the two, so we're going to factor that out. What is in common in this column of negative 2 and negative 4? Well, a negative 2 will divide into both evenly, and we go with the sign of what's closest. So x and negative 2x is going to be an x. 2 and negative 4 is a 2, and it's positive that's closest. And so I'm going to go ahead and write these factors in this spot. And so we have x minus 2 divided by 5x times 10x divided by 3 times x minus 2 times x plus 2. And so let's look at the colors of it, and I'm going to do this in color coded again and see what can cancel out. Well, I have x minus 2 twice, so that cancels out. I have an x in 2 locations, so that cancels completely out. The 5 and the 10 and the 3 are my numbers I have left. So, but a 5 and a 10 can reduce by dividing both of them by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. And then I have this x plus 2, and there's nothing for it to cancel out with, and neither is there anything for that 3. So let's go ahead and write down what we have left. So we're just going to multiply. So in the numerator, what I have left is I have this 2, and that's it. If everything cancels out in your numerator, you always have a 1. In my denominator, this entire denominator canceled, leaving me a 3 times x plus 2. So this is what the product is. The restrictions we need to take and look at our original denominator. So let's go ahead and go down to where it's factors. I'm going to go to this row here because I have it all factored out here. So 5x can't equal 0. 3 can't equal 0. Well, that doesn't need to be stated. 3 is never going to equal 0, so that's not something I need to worry about. So I'm just going to go ahead and erase that. That's not something to worry about. X minus 2 can't equal 0. X plus 2 can't equal 0. So when I solve each of these, this ends up becoming x can't be 0. And then I move the negative, this 2 over, and that becomes a positive 2 on the other side. So x can't be positive 2. And then we'll remove this 2 over again. But it's going to become a negative 2 this time because we have to subtract. And so x can't be negative 2. And so my 3 places it can't be is at 0, negative 2, and positive 2. Those are when this denominator is going to be 0. Those numbers, if I plugged in, I would end up with a 0 in the denominator. And remember, we cannot divide by a 0. So let's do one more. This one is going to take a little bit more factoring. So we're going to have to think through each of our spots. And so the first, I'm just going to go ahead and write out my 2 fraction bars, and we're just going to kind of fill in things as we go. The only one that doesn't need a factor is this denominator because there's not a squared term and there's not a common factor. Oops, minus 5. And now we're going to take each of the other spots one at a time and see what they factor out to be. So let's take the first numerator. And again, when we're doing this, we're going to use the boxes. We're looking to see what can factor out. So we have x squared, negative 6. So that product is negative 6x squared. We're looking to find out when is it going to equal 1x. And that would be when it's 3x times negative 2x. And again, it doesn't matter which spot you're filling these 2 in as long as they are in this diagonal. That first column, an x can factor out. The second column, a 3 can factor out. The first row, an x can factor out. Second row, a negative 2. And so that gives me in that first numerator x plus 3 times x minus 2. Now let's go ahead and take the second numerator. This one can be done with the difference of squares if you remember that rule. Or if you don't, the box method always works when you have a quadratic. They can be factored. You have the x squared, negative 25. So what multiplies to give us 25x squared? They will add to be 0x. That'd be negative 5x and positive 5x. And then we are going to fill those in here. First column, an x can factor out. Second column, a 5 can factor out. First row, an x. Second row, a negative 5, because it was closest with a negative. So we have x plus 5 times x minus 5. And the last one that needs to be factored out is the x squared plus 4x plus 3. And so we have x squared here, a positive 3 here. And so we're looking at 3x squared. What can multiply to give me 3x squared? That can add to give me a positive 4x. That'd be a 1x and a 3x. So this first column, an x can factor out. Second column, nothing can, so that's going to be a positive 1 because it's positive with the closest. First row, an x. Second row, a 3. And so that gives us just our last denominator. Now to get this a little bit cleaner, we're just going to go over to the next slide. And we're going to look at canceling. So when I look at this, I'm looking to see what things can cancel out. Well, it's x minus 5. There's another x minus 5 in the second numerator. This x plus 3, there's another x plus 3 in the second denominator. And then I'm going to look at what I have left. The only thing I have left in my denominator is x plus 1, and there isn't one of those in the numerator. So I've canceled everything that can cancel. And so I'm going to go ahead and write this as a fraction. X minus 2 is what I had left from the first fraction. X plus 5 is what I had left in the second fraction. And the only thing I had left in my denominator is that x plus 1. And so this is the product of those two fractions. Now I need to find my restrictions. And so again, I'm going to be looking at this denominator. And it's going to be based upon the denominator that goes all the way across on both fractions. So x minus 5 cannot equal 0. X plus 3 cannot equal 0. X plus 1 cannot equal 0. And so that would be when x is equal to or not equal to 5 is a problem. X is going to be a problem at negative 3, and x is going to be a problem at negative 1. That means those are the three locations that I do not have a solution. That's my restrictions. I want you to try to do number 4 on your own. And then we're going to look at the next slide, and I'll show you the solution. So you should have had 2 times the quantity of x plus 1 divided by x plus 4 squared. When you have the same thing written twice, the best way to write it is with a squared. And then our restrictions are when it was at positive and negative 4.